once again welcome to my channel. Another important topic in BEE, that is we are going to start today, that is called as electrical machine. So if you go broadly about electrical machine, because in normal daily life we always use the machine, motors in any domestic as well as industrial application. So electrical machine basically get classified into two parts. One is known as a DC machine and another is known as AC machine. The machine which work on DC supply, they are called as a DC machine. Machines which are working on AC supply called as AC machine. DC machine basically get classified into two parts. One is called as motor, that is known as a DC motor. Another is known as DC generator. Then three-phase induction motor and single-phase induction motor. And some special purpose motors are also present in different syllabus as well as practical use. So we'll focus. This is the roadmap for this entire series, that is act as another module for electrical machine. So today we first focus on the concept of DC motor and then we shifted to the concept of DC AC motors. So first we'll think about what is the meaning of, basically in simple word, generator and motor. Difference between generator and motor. So first important point in generator, because both are work on electromechanical energy conversion principle. That is, suppose this is a machine and in this machine if you apply the mechanical input and if you are getting electrical output, then such machine is always known as the generator. So simple work and mechanical energy get converted into electrical energy. But in opposite side, if you see the major difference of motor, in motor machine remain mostly the same but change of input take place. What is the input now in case of motor? In motor we always gives the electrical input, and we will get the output as a mechanical output. And when you're getting mechanical output, such machine is always called as motor. So in simple word, both generator and motors are work on electromechanical energy conversion principle. Means either electrical energy get converted into mechanical or mechanical energy get converted into electrical. So that is a basic concept behind motor and generator. And depending upon the supply, I've already known that motor may be DC or AC. That we'll see in next point. So without wasting time, we'll now focus on the first topic, that is DC machine. Because in last PPT you have seen that in both the conversion, machine always remain the same. Only what you have to change, input. If you apply electrical input, you are getting mechanical output, or you are applying mechanical input, you are getting electrical output. So that is the concept. But between both conversion, your machine always remains same, and that machine is always known as DC machine. So in exam, there is always first question, that is explain construction of DC machine. What is the construction of DC machine? So very simple construction, because most of the people by heart this one, but not necessary. It is very simple way to explain. So first point in DC machine, that is outermost portion of any machine is always called as the yoke. The first component of any DC machine or motor is known as yoke. It is made up from cast steel or cast iron, and basic function is to protect internal part of DC machine from external atmospheric conditions. So this is the part of the any machine is called as yoke. First component. Second component in DC machine, that is we have to generate the magnetic field. So most of the time there is some fixed number of magnetic pole inside the machine. It may be 2 pole, it may be 4 pole, depending upon speed and other requirement. So second part may be the magnetic pole. So every machine is wounded with certain number of poles. So this is a 4-pole machine. That's why I'm drawing the 4 poles inside the machine. So second important part of any DC machine is known as the magnetic pole. So second part is known as the magnetic pole. So first part is yoke, second part is pole. Magnetic pole is always made from high grade silicon steel to avoid the eddy current and hysteresis losses, and basic function of this magnetic pole is to create magnetic flux inside the DC machine. So this is the second part of every DC machine or motor, and we know that every motor and generator, every magnetic pole is electromagnetic nature. What is the meaning of electromagnetic nature? When you excite the pole, then and then only they create the magnetic field, and that's why to create the magnetic field inside the DC machine, certain number of copper conductors are wounded on surface of magnetic pole, and this winding is always called as the field winding. So another important point here, that is third part of any DC machine is known as the field winding. So if you observe properly, the stationary part, there is another part that is called as the base, because every machine is located on the base. So in exam, first you have to draw this part. First outermost portion is called as yoke. Then every machine, whether it is motor or generator, wounded with certain number of magnetic pole, and to excite the magnetic pole, certain number of copper conductor are wounded, that is called as field winding. So stationary part of any DC machine, this is all called as a stationary part, consists basically three components. One is known as yoke, second component is known as magnetic pole, and third part is known as the field winding. So these three components always come under category of the stationary part. And stationary part of any DC machine, because every time it is not necessary that you have to draw this diagram, is symbolically highlighted by the symbol that is called as F1 and F2, or maybe in series S1, S2. So this is a symbolic meaning behind the stationary part of machine. And what is the purpose of stationary part? They have to create the magnetic flux inside the machine. So this is about the first part and three component of the first part. Next we'll go to the rotating part of any DC machine. Rotating part of any DC machine is always known as the armature, and rotating part is circular in nature. That's why next part will be the armature, which is cylindrical in nature, to carry the armature conductor, So these are the slots to carry the armature conductor on it, and that armature conductor is called as the armature winding. So rotating part of first component, rotating part का रहेगा, that is called as armature. And on armature is a cylindrical in nature, and to carry the armature conductor, certain slots are provided on it. That slots carry the winding, and that winding is called as the armature winding. So second important part of DC machine is called as armature and armature winding. And all armature winding are internally connected to the most important part, that is called as the commutator. What is the purpose of commutator? That I'll explain. But it is made up from mica. So another part is called as commutator. Commutator is made up from mica. And final word, that is to collect the voltage or to give the voltage, two carbon brushes are always rested on surface of commutator, and they are known as the brush. So what is the rotating part of every DC machine? Is armature, which is cylindrical in nature, and n number of slots are in periphery, that is called as armature winding. And all armature winding are internally connected to the commutator. So third part is a commutator, and two carbon brushes are located on this commutator. So what are the different components coming in rotating part? This is the stationary part. So they consist, first part is called as armature, next part is called as armature winding, next part is called as armature winding, and then next is commutator, and finally is the brush. So four components are under category of rotating part, and every time it is not necessary to draw this diagram. Symbolically, rotating part of every machine is denoted by the circle, that is armature, and two carbon brushes, and terminal marking may be A1 and A2. Inside that you can write motor or maybe generator. So this is the rotating part of your DC machine, and this is the stationary part. Symbolically you can represent by DC machine. So in exam, when there is a first question, explain construction of DC machine, then your answer should be, you have to draw this diagram. First part, once again I repeat, rotating outside part, सबसे बाहर का part जो है, that is called as yoke, which is made up from cast steel. Basic function to protect internal part. Then second part will be the magnetic pole. They are electromagnetic in nature. To excite them, certain number of copper conductor are there. They are called as field winding. So field winding and pole are generate the magnetic flux inside the machine. And to cut that magnetic flux, we require the rotating part. And rotating part is known as armature, which is cylindrical in nature. and consists n number of slots on its periphery to carry the armature conductor, and that armature conductor is called as armature winding. And finally, all armature windings are internally connected, because what happens when you rotate the armature inside the magnetic field, there is generation of EMF, but EMF is a AC. We want DC. To convert that AC into DC, we require a mechanical rectifier, and that mechanical rectifier is known as commutator. And then finally, to collect the current or voltage, we use the two brushes resting on commutator. So in short, stationary part consists yoke, magnetic pole and field winding denoted by field winding, and rotating part is a armature denoted by A1 and A2 consists armature winding, commutator and brush. So this is the first important question, that is called as DC machine, and it is a construction remain common for both motor as well as generator. So welcome back again. We are continuing the same topic, that is we are already seeing what is the machine, then DC machine construction, and now it is time to start the actual topic, that is called as DC generator. So when you think about DC generator, I already explained that we have to give the mechanical input and then output will be the electrical, then such machine is always called as DC generator. So that is about the DC generator that I already explained. Now the first important question always coming to the exam, that is derive the EMF equation of DC generator. Derive the EMF equation of DC generator. So in this question, first you already know that you have one construction where there is a field winding and there is a armature winding. So this is the two part inside this one, and we already see what is the meaning behind the field winding and armature winding. So this is a pictorial representation. This is the field winding and this is the armature winding. So first point, when you rotate your armature inside the magnetic field, when you rotate, because when light goes off, you always give the mechanical energy. So due to mechanical energy, your armature start rotating inside the magnetic field, and when your armature start rotating inside the magnetic field, it will cut the magnetic field, and when it will cut the magnetic field, there is generation of EMF, and according to Faraday's law, how you describe the EMF? d phi by dt. It is already know what is a d phi. D phi is known as change in flux. D phi is known as change in flux, and what about dt? Dt is time taken. So simple expression for Faraday's law, that is whenever we rotate armature inside the magnetic field, there is generation of EMF across the armature, which is given by Faraday's law mathematically d phi by dt, where d phi is a change in flux and dt is a time taken. So this is the first simple expression about this one. Now we have to think about, when I rotate armature by one revolution inside the magnetic field, how much flux it will cut? It will cut P into phi. What is the meaning of P? P is the number of pole, phi flux produced by each pole, because we know that pole may be 2, pole may be 4, so depending upon pole, the magnetic flux will be there. So this is a change in flux, and what is the time taken? For 1 RPM point of view, it is a 60 by N. So if you simplify, then it is become phi n by 60. So this is a generated EMF across single conductor of armature. But we know that armature is wounded with certain number of turn, and if I say Z is a number of turn, then E equals to become phi n by 60 is the EMF per conductor multiplied by number of conductor, that is equals to Z. So that gives you total EMF generated inside the generator. And now the important point, that is another one term that you understand afterwards, that is divided by one parameter, that is called as A. A is known as number of parallel path. So number of parallel path is a concept of winding, whether it is lap or wave winding. These are the two winding used for winding of DC machine. So A always remain equals to 2 for wave winding, and A equals to remain P for lap winding. And this is the combinedly EMF equation for DC generator. So only 3 or 4 steps you required to go for EMF equation of DC generator, where P equals to number of pole, what about phi equals to magnetic flux, what about N equals to, N is a rotational speed of armature, What about Z equals to armature conductors, number of armature conductors. And what about A equals to, A is known as parallel path, and this parallel path, that is A equals to always remain equals to 2 and A equals to remain equals to P. It is for wave winding and it is remain for the lap winding. So once again I repeat the entire derivation. It is a most important question. Derive the EMF equation of generator. So whenever we rotate armature inside the magnetic field, because in generator what happens, light goes off, then we start the generator gives the prime movers gives the input to the generator, that is a mechanical. Due to mechanical, armature start rotating inside the magnetic field, generate the EMF by Faraday's law, E equals to d phi by dt. D phi is a change in flux, dt is a time taken. So when one revolution completed by armature, it will cut how many flux? P into phi. What is a P? Number of pole. What is a phi? Flux created by each pole. And what is the rotational speed of armature? 60 by n. So simple. This is the EMF generated per conductor. This is the EMF generated per conductor. But we know that in armature there are n number of conductor rotated on its armature. That number we can say Z. Then we have to multiply by Z to get the total EMF. So this is the final expression for the total EMF. So total EMF E equals to P phi Zn by 60A. A is a new concept. It is dependent upon the winding. A equals to 2 for wave winding and A equals to P for lap winding. And another parameter is straightforward. P is a number of pole, phi is a magnetic flux, N is a rotational speed of armature, Z is a armature conductor, and A is a parallel path. So this is a 4-mark question. Very straightforward and simple answer. Derive the EMF equation of DC generator. After the EMF equation, another important point remain here, that is what is the direction of this EMF, and direction of EMF is always given by Fleming right hand rule. In 12th standard also you are done. So direction of EMF, direction of generated EMF is given by Fleming right hand rule. So what is the Fleming right hand rule? If you consider thumb like this, then I can show with only the arrows. So 3 important parameters are there, that is keep in mind, because we generally used to write L, not necessary. First you have to think in mind, that is what is a generator. Generator take the mechanical input. So keep in mind that thumb indicate the mechanical quantity in both right and left hand rule. First finger, index finger indicate the magnetic field direction and second finger indicate the electrical quantity. So in case of generator, when light goes off, first important point you have to give what? Motion. कहाँ दे रहे मोशन? You have to give the motion to the armature. तो सबसे पहला point, you are giving motion to the armature. कहाँ दे रहे? Inside the magnetic field. कहाँ दे रहे? Inside the magnetic field. Inside the magnetic field. Inside the magnetic field. और क्या generate हो रहा है? Generate हो रहा है EMF. So simple word, क्या generate हो रहा है? EMF. कहाँ generate होगा? Across armature. So when you rotate armature inside the magnetic field, there is generation of EMF. So simple, that is motion given in magnetic field, generation of EMF. So that is the simple meaning behind the direction of EMF, and that is given by Fleming right hand rule. And this is the diagram to illustrate the right hand rule. What? Motion given in magnetic field, and there is generation of EMF. So this is a simple, sometime ask the direction of magnetic field, that you can add as a Fleming left hand rule. After the Fleming left hand rule, next point remain, what are the types of DC generator now? So there are 2 types of DC generator. One is known as series generator. The first type of generator is known as series generator. So diagram is very simple. So another question, that is write short note on DC generator. So there are 2 types of DC generator, series and shunt. So now think about what is the circuit diagram for series generator. If you think about circuit diagram of series generator, then when you connect the field winding, first important point, when you connect the field winding and armature winding, field winding and armature winding, This is my armature winding, denoted by A1, A2. I already explained this is the symbolic representation of armature. Armature is cylindrical in nature, that's why shown by the circle, and the field winding connected in series, and that's why generator is always called as series generator. So simple representation of series generator means when we connect armature winding in field winding and field winding connected in series, that's why it is called as S1 and S2. So this is my armature winding, this is my armature winding, and this is my field winding, So construction point of view, explanation point of view, it is very simple. When I connect armature winding and field winding in series, generator is known as series generator. So now the working principle in short, when you rotate armature, because what you have to give, first you have to give the motion. So I am giving here motion. What I am giving to the generator? I am giving the motion. Kaha motion de rahe? I am giving motion because it works as a generator, so I am writing here G. When I give the motion to the armature inside the magnetic field, 100% there is generation of EMF, that is equals to E, and we already know the magnitude of EMF is P phi Zn by 60A. So this is the first job take place. When you give the motion, there is generation of EMF. When there is generation of EMF, there is surely generation of current, and that current is called as armature current, because your armature has some resistance that denoted by Ra, then E by Ra, some armature current is passing through the armature and passing through the field winding. And when it is passing through the field winding, that current is called as ISC. ISC will be generate the magnetic flux, and the remaining voltage is available across the terminal. That voltage is called as V, and this is given to your load. This is given to your load. So this is a very simple explanation, that is when you give the mechanical input, we will get the electrical output. So if I elaborate all the parameter, then first parameter we observe, that is E. E is a generated EMF. E is a generated EMF. What about P? Sorry, what about Ra? Armature resistance. What about Ra? Armature resistance. What about Ra? Armature resistance. Next point we decide, that is some resistance for field winding, then it is called as RAC. So RAC is RSE is a resistance of series field winding, resistance of series field winding, resistance of series field winding, and then V, terminal voltage across the load, terminal voltage across the load, IA, armature current, IA is armature current, and what about ISC, series field winding current, series field winding current. So these are the parameters of DC generator, and if you apply the KVL now, so what is the voltage equation become? Because voltage is generated like plus minus E, then E is a first generated EMF. You are traveling from negative to positive. Some drop take place across armature, that I take IA into RA, that is a drop in armature, that has to overcome this E. Then some drop across series field winding, that is ISC into RAC, ISC into RAC, this is the ISC, minus ISC into RAC, and बचा हुआ जो भी voltage रहेगा, that is available here as a plus minus, and that voltage is called as V, that is equals to 0. From that you can easily say that generated EMF always equals to V plus IARA plus ISC RAC. But if you simplify, then V equals to, E equals to V plus IA and RA are same, that's why equation become RA plus RSE. So this is become the voltage equation of generator. So simple KVL. Why IA here? Because IA and ISC are same, because they are series current. So this is also, you can say, current equation. So this is a voltage and current equation of DC series generator. So this is the entire explanation about series generator. Once again I repeat, when you apply the motion, there is generation of EMF. That EMF drives the current and satisfies the terminal load requirement. So this is the explanation behind series generator. Now just we want to see the what is the characteristic of series generator. Then if you see in the diagram, series generator always, if I draw the characteristic of E versus load current, whatever it may be, because load current also remains same in generator. So what will happen here, initially when you start the generator, there is very small amount of flux that is called as a residual magnetic flux, but once the generator is start, step by step it develops the voltage. That's why rising characteristic is a VI characteristic of DC series generator, VI characteristic of DC series generator. And due to rising characteristic, it is not suitable for industrial and domestic application, because industrial and domestic application require constant voltage. That's why DC generator is best suitable for battery charging application, battery charging application. Second, it is more suitable for street lighting, power supplies. So these are the some applications of the series generator. So this is the characteristic and application, the first part, that is called as series generator. Next part of generator series, that is called as a shunt generator. Second part रहेगा shunt generator. So simple construction again, I already explained. When you connect now field winding and armature winding in parallel across each other, or in parallel across, you can say load simply, then whatever construction developed, that construction is called as shunt generator. So it works as a generator. So I write G here. This is my F1, F2. This is my A1, A2. So what is the action again take place here? Armature resistance remain RA. Field winding resistance, instead of RAC, it is become RSH, because winding is in shunt. Whatever voltage developed across the load. So first, when you apply the motion to the generator, there is generation of EMF across armature. And there is a resistance, there is a voltage, so some current is passing through it. That current is called as IA, and this current is known as ISH, and this current is known as IL, and this is your terminal voltage, that is equals to V. So same parameter, whatever we define in series, only difference RAC become RSH and ISC become ISH. But another beauty of shunt generator, that armature winding is connected parallel and this portion always remain constant. That's why when you apply the KVL is applied across this part only. So negative positive it become plus E, then minus IRA, drop across armature, and remaining is directly, if you mark the plus minus, remaining is V equals to 0. From that E equals to रहेगा V plus IARA. So this is a simple voltage equation for shunt generator. And if you think about current equation, then in current equation, if you apply KCL here, then IA become equals to ISH plus IL. So this is the current equation of shunt generator. But I already explained that is in shunt generator, the field winding is permanently connected across the supply. That's why it developed the constant voltage, because it is called as a constant flux machine. And due to constant flux machine, it roughly developed the constant voltage. So this is the E versus IL characteristic of shunt generator, and that's why it is suitable for all industrial and domestic application. So this is another important point in shunt generator. So this is the characteristic and application of the shunt generator. Starting the another part, that is, we already covered the DC generator, what is the construction of DC machine and everything. Now it is time to elaborate what is a DC motor. So it is a just extension what is a DC motor? It is just extension of generator. So we'll starting the next topic, that is called as DC motor now. We already explained that DC motor is nothing but it convert electrical energy into mechanical energy, and construction of DC motor remains similar to DC generator, and that we already say that is a DC machine. Now we have to see what is the working principle and what are the different types of DC motor. So that is the motivation behind this video. So first point, that is what is the working principle of DC motor. So first point रहेगा, that is working principle of DC motor. Working principle of DC, that is motor. We are already familiar to the right hand rule. Now it is time to go for left hand rule. What is the left hand rule stands for? That is left hand rule is applicable for motor and right hand rule is applicable for generator. So in left hand rule, we know that in motor what we use first, that is we always apply the electric current first in magnetic field and then it generate a force. That's why reverse procedure. We already know that we have armature, and this armature is placed in magnetic field. So in case of motor, you have to apply the current, that is current. When you apply the current, your all armature conductor become current carry conductor and they are placed in magnetic field, and that's why they experience a force, and due to force your armature start rotating. So that is a very simple concept about the DC motor. So once again I repeat, when you apply the current, then your armature conductor, whatever armature conductor on armature, they become current carry conductor, and current carry conductor placed in magnetic field, it experience a force, and that is given by Fleming left hand rule. So working principle of DC motor is always depend upon Fleming left hand rule. We are already familiar to the right hand rule. So what is a Fleming left hand rule? Same thing, that is this is suppose your left hand rule. I am showing with help of arrow. So exactly reverse. Again I repeat, that is thumb indicate the mechanical quantity in both the laws. First finger magnetic field and second finger indicate electric quantity. So in case of motor, what we give first? We give the current, because we know that we want to start anything like fan, anything, we have to apply the current first. So when you apply the current, your armature conductor become current carry conductor and they place it inside the magnetic field and they experience a force. So this is a very simple working principle for 2 or 3 marks. What is the working principle of DC motor? So once again I repeat, that is whenever current carry conductor placed in magnetic field, it experience a force. So simple word may Fleming left hand rule describe the working principle of a DC motor. So that is the first important part of DC motor. Next important question, another important point आता है, that is what is a back EMF? What is a back EMF? That is generally called as EB. Back EMF, that is generally called as EB. So we know that when you rotate your armature, because due to force, we are already familiar that is due to force your armature start rotating inside the magnetic field, and it again cuts the magnetic field, and that's why there is generation of EMF. But in case of motor, it is always correlated as a EB. EB is called as back EMF. And magnitude of EB always remains same, that is P phi Zn by 60A. So in generator it is called as generated EMF, but in case of motor it is called as back EMF. So when you draw the figure for the generator, motor, instead of G I am writing M here now across the armature. There is also generation of EMF, but that EMF is always called as the back EMF. Once again I repeat, when you apply current carry conductor, your armature become current carry conductor, they rotate inside the magnetic field, cut the magnetic field, and according to Faraday's law, there is generation of back EMF across the armature conductor. Magnitude remains same, P phi Zn by 60A, and it is highlighted like this. Why it is called as a back EMF? Because it opposes the supply voltage, that is called as a cause by Lenz's law. That's why instead of generator here we say the back EMF. So that is another important concept remain in motor. What is the meaning of back EMF? After the back EMF, the last point in motors, that is you have to explain what are the types of motor. So there are two types of motor again. So I am writing here again types of motor. So there are two types of motor. One is known as series motor and another same as a shunt motor. So first we'll think about what is the meaning of series motor. Same construction, same meaning about the generator and motor. So when you do this topic, always correlate series generator with series motor. What we say in series generator, that is when we connect the armature winding, and field winding in series across AC supply, across DC supply, the motor is called as series motor. So simple construction diagram of series motor, that is when we connect the field winding. So this is your field winding and this is your armature winding. So when you connect armature and field winding in series across each other, there is a motor called as series motor. Terminology remain the same. Armature having some resistance called as RA, field winding having some resistance called as RAC. This is the construction of series motor. Now how this motor is work? It is very simple. When you start any motor, first you have to switch on the supply. When you switch on the supply, your motor takes current, and that current, if I say that is I load, then same current taken by series field winding, that is called as ISC, and same current taken by your armature also. So when your armature take current, your armature conductor become current carry conductor. What? Armature conductor become current carry conductor, and when current carry conductor placed in magnetic field, they experience a force. So force is always exerted on armature, and due to force your armature start rotating. When your armature start rotating, they again cut the magnetic field, and according to Faraday's law, there is generation of EMF, but we generally call that EMF as a back EMF. I already explained what is the meaning of back EMF. In generator it is called as EMF, but in motor it is called as back EMF. And when there is a EB, then automatically your motor start rotating. So working principle remains same as well as equations remain same. If you apply the KVL, just you have to apply KVL anti-clockwise if it is motor and clockwise if it is generator. So if you start from here, then it is become negative positive, to plus V minus ISC into RAC, that is a drop take place across series field winding, then minus IRA, that is a drop across armature, and then positive to negative, that is become back EMF, and that is equals to 0. From that V equals to become V equals to become EB plus IA into RA plus RAC. Why IA plus RAC? Because in same series motor, ISC always equals to remain IA. That is the remaining current equation for motor, and this is become voltage equation for the motor. So what change here? In generator, E will be on this side, V will be on this side. But in motor, both are changing their position. That's why V equals to EB plus IRA become voltage equation. And what about this? This is known as current equation. So this is a simple analysis for DC series motor. And after DC series motor, what kind of characteristic it provides? So now most of the time in motor we are thinking about torque and the speed. So if you correlate now, whatever generated EB, then EB always equals to रहेगा P phi Z N EB we already discussed. EB always equals to रहेगा P phi Z N by 60. This is my EMF equation. But we are interested now in speed. That's why can I say N equals to हो जाएगा EB into 60A divided by P phi Z. But most of the time EB always V minus RA remain constant, 60 remain constant, A remain constant, P remain constant. That's why N is a directly proportional to 1 upon phi. This is the most important equation in case of DC series motor, that is N is inversely proportional to the phi. That's why at start, if you think at the start, there is very less amount of flux present inside the machine. That's why if N is inversely proportional to phi, at start DC series motor always start with very dangerously high speed. And that's why we never start our DC series motor without any mechanical load. Take example of mixer grinder. In mixer grinder we put first load and then we use start the motor. Why? Because in mixer we use inversal motor, which is a combination of DC and AC series motor. And that's why this is the only drawback of series motor, that series motor always start with dangerously high speed, because at start flux is very small, and if flux is very small, it rotates with dangerously high speed. But once current is passing, load is there, then automatically flux increases and speed become normalized. That's why if you draw the characteristic of, that is speed versus the current, as current increases, speed decreases. So this is the characteristic for series motor, and due to that, generally in motor, torque is directly proportional to flux into Ia. That's why it always generates very high torque. That's why these motors are basically suitable for heavy high starting torque requirement. Where high starting torque required, like lift. You observe the lifts, electric locomotive, then mixer grinder, cranes. These are the some application where we deserve the high torque. So generally series motors are known as high torque motors, and that's why their application remain in terms of electric lifts, because it requires high starting torque. Then locomotive stands for long distance train. Then local trains, that is called as a tractions. Fourth application इसका रहेगा, that is mixer grinder or food processor. So these are the some applications of DC series motor. So DC series motor is always called as high torque motors, and they are suitable for different application like electric lift, cranes, mixer grinder, traction. Many applications are for DC series motor. After DC series motor, next topic रहेगा DC shunt motor. So already we discussed what is a series generator and shunt generator. Similarly, shunt motor is similar to the shunt generator. What is the construction circuit diagram for shunt motor? When we connect now field winding and armature winding in parallel across the supply. This is your motors, that's why we have to give the supply. So this is the supply. Then motor is called as shunt motor. Same terminal marking. This is your F1, F2. This is your A1, A2. And only difference, because if you observe the circuit diagram, that shunt generator and shunt motor diagram remain the same. Shunt generator and shunt motor diagram remain the same. Only difference is that the direction of current. So when you apply the supply, surely there is a flow of current. That current is called as IL. IL gets split up as a IA and ISH. Now, like series motor, what will happen in shunt motor? In shunt motor, that your field winding is connected permanently across the load. And as field winding is connected permanently across the load, it have a constant voltage, means it generates the constant flux. And when there is a constant flux, it will produce the constant speed. That is the important difference between series motor and shunt motor. In series motor, field winding is connected in series with supply, and that's why it have variable flux. But in shunt motor, they are called as a constant flux because they are connected permanently across the supply. And that's why if you apply the now KVL in reverse direction, or before that, when you apply the voltage, current carry conductor again place in magnetic field, it generates the back EMF. So this is the complete structure of shunt motor. And if you apply the KVL, then KVL start from V, that is always plus minus, means negative to positive is V, minus IRA, that is a drop across armature winding, IRA, and remaining is your back EMF, that is equals to 0. From that, V equals to become EB plus IRA. So EB plus IRA is the voltage equation for shunt motor, and IL, if you apply our KCL here, then IL equals to IA plus ISH becomes current equation. So similarly, only difference is taking place that V and EB are changing their position. So V and EB are changing their position, that is the only difference here. And we know that in this motor, that is N is proportional to EB. क्या formula हुआ था? EB into 60A divided by P phi into Z. If you observe here, EB remain constant, A remain constant, P remain constant, flux also remain here constant. That's why this motor always generate the constant speed. That's why if you observe the characteristic of both, one is known as constant motor, constant speed motor, and another is known as variable speed motor. So this is the speed characteristic of DC motor, and that's why it is suitable for constant torque. Where we require the constant torque, all applications, all industrial and domestic application. For example, that is in fan, we generally fan motors, then refrigerator, compressor, many application, whatever industrial and domestic application we observe in normal where we require the constant speed, then we use the shunt motor. So basic application of shunt motor, that is all the drives require constant speed. All the drives required constant speed. So in university syllabus there is a point, that is we want what is the meaning behind, because there is only one question, that is either you explain the working principle of DC motor, that is a simply Fleming left hand rule, or you can explain a DC motor and DC series motor and shunt motor. So this is the meaning behind the short note point of view, what is the DC motor. So next topic in machine, generally called in Mumbai University syllabus, that is called as single phase induction motor, and it always cover the 4 to 6 marks, and this is also very simple topic. So now we will concentrate on another next topic, that is AC motor. Under AC motor we will concentrate now single phase induction motor. Single phase induction motor. Under this, the first question is always explain construction and working principle. Construction and working principle. But in construction and working principle, the most important question here, why single phase induction motor is not self started. This is any university question paper, if you observe, it is very bonus mark question, just 3 to 4 marks. Explain construction working principle of single phase induction motor, are supported by why single phase induction motor is not self starting. So first we will focus what is the construction of single phase induction motor. So like a DC machine, there is also two parts, one is a stationary, another is a rotating part, but terminology get changed. The stationary part of any AC motor is always known as a stator, and we know that stator is responsible to generate the magnetic flux. So certain number of poles are there, and on stator surface there are n number of copper wire turns are there, and they are connected to your single phase AC supply. Single phase AC supply. So this is the construction of stator. So this is actually your stator. This is actually your stator, and this is your stator winding. Stator and stator winding. So stationary part of any AC motor is called as stator, and winding provided on it is called as stator winding. And in case of single phase induction motor, this stator winding is connected to single phase AC supply. And what is the function of the stator winding? Function of stator winding is to create magnetic flux inside the machine. What is the job of field winding? Same job here of stator winding, to produce the magnetic field. And the rotating part of any AC motor is always called as the rotor. The rotating part is always called as rotor, and the conductor mounted on it is always known as rotor conductors. Rotor conductor. So instead of armature, word is now rotor, and this is known as rotor winding, and this is known as rotor. So this is a very straightforward and simple construction of single phase induction motor. Two parts are there. One is called as a stationary part, another is called as a rotating part. Stationary part is known as stator, rotating part is known as rotor. Winding mounted on stator is called as stator winding, and winding on rotor is called as rotor winding. So this is a simple first part, what is the construction of single phase induction motor. Now the working point of view, what is the working of single phase induction motor? When you apply single phase AC supply, to the stator winding create alternating magnetic flux. Because your supply is alternating, that's why your nature of magnetic field is also alternating. That's why if you apply the single phase AC supply, you will get alternating magnetic flux. This is your phi maximum, this is your negative phi maximum, and this is the analysis of one cycle that your stator winding always create the alternating magnetic flux, and this alternating magnetic flux is cut by the rotor. This alternating magnetic flux is cut by the rotor, and we know that when there is a cut of flux, there is generation of speed or torque. But important point, what kind of torque generated in single phase induction motor, because your supply is AC, that's why this motor always generate the alternating torque. That is, during positive half cycle it generate the positive torque, and during negative half cycle it generate the negative torque. And if you see the resultant torque, then resultant torque acting on the shaft, torque acting on the shaft over entire cycle is 0, and that's why single phase induction motor is not self-started. So this is a very simple and straightforward answer why single phase induction motor is not self-started. Once again I repeat, when you apply single phase AC supply is alternating, it generates the alternating magnetic flux. When there is alternating magnetic flux and torque are proportional, that's why positive half cycle produce positive torque, negative half cycle produce negative torque, and resultant torque acting on the shaft is always equals to 0. And this is the basic drawback of all single phase induction motor. Due to supply, they are not self-started. So this is the first important question in university exam or university exam paper, that is why single phase induction motor is not started. And the second part in single phase induction motor as per syllabus, that is then how you start the single phase induction motor. So next part रहेगा starting methods of single phase induction motor. So next topic रहेगा what are the different starting mechanism of single phase induction motor. Starting methods for single phase induction motor. The first starting method is called as split phase induction motor. Second starting method is known as capacitor start single phase induction motor, and third method is known as capacitor start capacitor run induction motor. So there are three methods. There are many also, shaded pole and all, but as per syllabus there are three starting method of single phase induction motor. They are known as split phase induction motor, capacitor start induction motor, and finally capacitor start and capacitor run. Sometimes it is called as permanent capacitor motor. So these are the three types we have to discuss in this video. That is the three different starting method of single phase induction motor. So first part we will go for what is the meaning of split phase induction motor. Split phase induction motor. As name suggests, what is the meaning of split phase? You have to split the phase, means your single phase you want now two phase, because single phase motors are not self-started, so we want two phase induction motor. That's why construction of this motor, if you observe, there are two winding. This is your single phase AC supply, suppose. So there are two winding. First winding is called as starting winding, which is connected in series with centrifugal switch, and there is another winding which is called as main winding or running winding, and they are connected like this. So this winding is always called as starting winding. This winding is known as starting winding, and this winding is always known as the running winding. So instead of single winding, there are two winding. That's why name is a split phase motor, and that's why starting winding is made up by high resistance and low reactance, that is low X. This is the important feature of starting winding, is made up by high resistance and low reactance. But what about running winding? Running winding is made up of hamesha, that is low resistance, exactly reverse, and high X, that is high reactance. So this is the structure behind the windings of the motor, and as usual there is a rotor and rotor winding, they are placed inside the motor. So this is the construction. This is your centrifugal switch and this is your single phase AC supply. So this is the first starting method we generally use in case of single phase induction motor, known as split phase induction motor. Now question in your mind, how this motor gets started. Now you observe, if I start the supply, then main current get divided into two parts. One current becomes starting current because initially centrifugal switch is closed, and another current become main current. And if you draw the phasor diagram for analysis purpose, I take voltage as a reference. Where should be position of IS? IS is lagging less because it having low reactance. That's why this is a current taken by IS and this is a current taken by main winding, because main winding having high X and this winding having low X. That's why automatically there are two current and two fluxes. Flux produced by starting winding and flux produced by main winding, and that's why there is always split phase angle called as alpha take place between two winding. And now what will happen here? Instead of one alternating flux, there are two alternating flux, and resultant flux you can join like this, that is resultant current you can join like this by law of parallelogram. This is your main current of the motor. So this is a roughly, or this is the power factor of the power factor angle of the motor, because V and I angle is a power factor angle. But important point here, due to two flux there is an interaction take place and there is a starting torque, and due to starting torque your motor start rotating, and once motor start rotating and achieve 80% or 60% speed, then by centrifugal action your switch become disconnected and then it run as a single phase induction motor. So this is the first starting mechanism of single phase induction motor. And if you draw the characteristics, then initially this motor get low torque start, and once motor gets started, then your starting winding is disconnected. Starting winding is disconnected at particular interval, and then it run as a single phase motor. Matlab initially it run as a two phase motor. Initially it runs as a two phase motor. So this is a roughly characteristic of single phase split phase induction motor. So once again I repeat, instead of one flux we generate the two flux. Once motor get the starting torque and started, then by centrifugal action your switch is disconnected and then motor run as a single phase induction motor. So application, we already know that fan is a best example for single phase induction, mixer, grinder, many domestic and industrial application where we use single phase supply, we generally use the single phase split plate motor. Now the important point, what is the drawback of split phase induction motor? The splitting angle between starting winding and main winding is very small. That's why these motors are generate very low amount of torque, and that's why they are not suitable for high torque application. And this drawback of split phase induction motor is overcome in next starting method, that is called as capacitor start, capacitor run single phase induction motor. So second starting mechanism of single phase motor is known as capacitor start induction motor. So what is a minor change take place in this case? That is, your main winding remain as it is, main winding remain as it is, then centrifugal switch remain as it is, but in series with centrifugal switch we connect one capacitor and then there is a starting winding, then there is a starting winding, and this is your again single phase AC supply, single phase AC supply. This is your starting winding, same phenomena, starting winding, which consists low X and high R. This is your main winding, or you can say running winding also, main winding or running winding. This consists low R but high X. So this is already clear, that is high X, this is a structure, main winding and this winding. Now in this case motor, again it take two current, one is known as starting current and it is known as main current, and phasor summation of starting and main current is your total current. But if you draw the phasor diagram in this case, how many flux are there? Again there are two flux, same mechanism, no change in mechanism, two fluxes are there. But if you draw the phasor diagram, then this is remain V. Where is the position of I main? Remain as it is. Where is the position of V here? V remains suppose this axis, I may remain this axis, but we know that when there is a large amount of capacitor reactance is there, then capacitive current become leading one. So starting current become leading. An important point for us, that is splitting angle between main winding and starting winding is alpha is larger than previous motor. And if your splitting angle is larger than this one, then you will get higher torque than split phase induction motor. That is the advantage of capacitor start single phase induction motor. And again, phasor summation of these two is again your main current, and you observe that in main current also there little bit improvement in power factor. So power factor improves between in this motor. So this is the simple structure behind the capacitor start single phase induction motor. But advantage of this motor, working remains same. When you apply single phase supply, two flux created, motor will start as a two phase induction motor, and once it attains the 80% speed, then by centrifugal action switch get disconnected and then it remain as a single phase induction motor. So that is the second mechanism remain the same, only we increase the flip phase angle by adding capacitor in series. That's why name become capacitor start single phase induction motor. Now the third type come into this part, that is permanent capacitor. Third type is known as permanent capacitor motor. Permanent capacitor motor. So in case of permanent capacitor motor, the most of the application permanent capacitor matlab we remove the centrifugal switch. This centrifugal switch is disconnected, and now motor run continuously as a two phase induction motor. So instead of single phase, capacitor permanently remain in the winding and motor run as a two phase induction motor. That start type is called as permanent capacitor motor. So 6 marks or 8 marks there is a question, explain different starting mechanism of single phase induction motor. The first is split phase induction motor, second is capacitor start, and minor modification in capacitor start. We don't want now single phase, we run as this motor as a two phase. Capacitor remain permanently inside the motor, so motor will get very good torque and remaining, but it is not remain single phase, it work as a two phase induction motor. So these are the three starting mechanism of single phase induction motor. So in single phase induction motor, two questions are important: why single phase induction motor is not self started, and what are the different starting mechanism of single phase induction motor. Hi, so welcome back. Again we are going to cover the last part of machine topic, that is called as three phase induction motor. Actually it is a very big topic. It acts as one three phase induction motor. It acts as a one subject basically, but as per Mumbai University syllabus we have to cover only two important questions, that is what is the construction of three phase induction motor and how it what is its working principle, and what are the advantage of three phase AC motor over single phase AC motor. So first point in three phase induction motor, that is what is the construction of three phase induction motor. What is the construction of three phase induction motor? As name suggests, it is a three phase, so but obvious supply will be the three phase AC supply. So if you draw the symbolic representation, then we are already familiar in single phase induction motor. The stationary part is always called as a stator. Stationary part is always called as a stator, and rotating part is always called as the rotor. And instead of single phase AC supply, we connect the three phase AC supply, which is denoted by R, Y and B. So this is a simple schematic representation of three phase induction motor. Stationary part is called as a stator and rotating part of is called as rotor, and it is connected to your three phase AC supply. So this is a very simple meaning first about the construction of three phase AC supply. To construction point of view, three phase induction motor get classified into two parts. One is known as stator, and another is known as the rotor. The stationary part, but obviously is called as a stator, and rotating part is called as a rotor. So this is the first introduction part of three phase induction motor construction. Now we think about what is the meaning of a stator. The first part is a stator. We already know that stator, basic function of stator is to create the magnetic flux inside the machine, and that's why if you look the construction or if you look the structure, this is your three phase AC supply lines that is denoted by R, Y and B, and Stator winding is generally star or delta connected. In three phase there are two types of connection. One is either star or delta. That's why stator always consists three phase either star or delta connected winding. Three phase always star or delta connected winding. They are denoted by R, suppose Y and B, and common point if you add, that is neutral. Then one more line here, that is act as a neutral. Then R connected to R, Y connected to Y, and B connected to the supply line, that is equals to B, and the neutral point is connected to the neutral. So basically this is your structure of a stator winding. It is a star connection. If it is a delta connection, then also diagram remains same, only delta connected winding is there. So simple word means stator of three phase induction motor consists three phase star or delta connected windings, distributed delta connected winding, and basic purpose is to create rotating magnetic field inside the machine, and that rotating magnetic field always rotate with a synchronous speed that is given by 120 F by P, where F is a supply frequency, F is a supply frequency, and what about P? P is number of magnetic pole. P is a magnetic number of magnetic pole. So when you connect your three phase star or delta connected winding to the three phase AC supply, the stator winding or the stator will be generate the rotating magnetic field, and that rotating magnetic field always rotate with a synchronous speed ns equals to 120 F by P, where F is a supply frequency and P is a magnetic pole. So this is the structure of stator of three phase induction motor. Now we'll focus on next part, that is what is the rotor structure of three phase induction motor. Rotor point of view, three phase induction motor rotor get classified into two parts. One is known as squirrel cage rotor, and another is known as slip ring rotor. Squirrel cage and slip ring rotor. And according to that, your three phase induction motor get classified into two parts, either squirrel cage three phase induction motor or slip ring three phase induction motor. So there is a minor difference in rotor structure of these two rotor. If you think about the squirrel cage, we already know that rotor is a cylindrical in nature. So in both case, rotor is cylindrical in nature, which is wounded on the shaft. So this is a shaft of three phase induction motor. Same here, this is the shaft, and rotor conductors are wounded in squirrel cage nature. It will look like a squirrel, how squirrel cage travels. So it is a squirrel cage rotor conductor. So this is called as a rotor winding. Rotor winding is in squirrel cage nature. That's why this type of motor is called as squirrel cage motor, and all the rotor conductor are short circuited at the end by means of end rings. So these are known as end rings. So in squirrel cage rotor, all the rotor conductor at the end are short circuited by the two end rings. That's why there is no arrangement to add some external resistance inside the squirrel cage. So this is the structure of squirrel cage. So what about slip ring? Structure almost remains same. These are the rotor winding or rotor conductors on slip ring induction motor, but instead of short circuiting at the end, these rotor conductors are connected to the three slip rings which is wounded on the shaft. These are known as a slip ring, and all rotor conductor are connected to slip ring, where you can add the external resistance which is useful for speed control purpose, and that's why this rotor is called as slip ring rotor. So rotor construction point of view, first part we cover, that is a stator, and from rotor point of view this motor get classified into two parts, squirrel cage rotor and slip ring rotor. In squirrel cage, all rotor conductors are short circuited by end rings, so there is no arrangement to add some extra resistance inside the rotor. But in case of slip ring induction motor, you can say that all rotor conductors are connected to the slip ring by means of slip rings. That's why name is slip ring induction motor. But due to this arrangement, we can add some external resistance in it so that we can control the speed of the motor. So speed control purpose, slip ring induction is motor, and constant speed, the squirrel cage induction motor is speed. And according to that, according to the rotor construction, your three-phase induction motor or get classified into two parts known as three-phase squirrel cage motor, and second part is three-phase slip ring motor. So when there is a question, explain construction of three-phase induction motor, so you have to explain stator and you have to explain the rotor. Stator is a star connected winding. Basic function is to rotate the generate the rotating magnetic field to produce the speed of ns, and another part is a rotor. There are two types of rotors, squirrel cage and slip ring rotor. According to that, your three-phase induction motor get classified into squirrel cage motor and slip ring motor. So this is about construction of three-phase induction motor. If you now think about the working principle, the working principle is very simple. When you apply, so now we have to consider what is the working principle of three-phase induction motor. Working principle of three-phase induction motor. So when you apply three-phase AC supply to the stator winding, three-phase AC supply to the stator winding, I make the symmetrical representation of roughly stator. This is your stator or stator winding. Then the stator winding continuously generate the rotating magnetic field of ns, and that rotating magnetic field is cut by the rotor winding. And when this flux is cut by rotor winding, there is generation of EMF across the rotor conductor, and the basic cause of this generation of EMF according to Lenz's law is a relative speed between stator speed and rotor speed. If you say rotor speed is n, so initially rotor speed is n equals to 0, and to reduce the relative speed between ns and n, your rotor start rotating in same direction with the stator, and that's why motor start rotating. So this is a simple working principle of three-phase induction motor. Once again I repeat, when we apply three-phase AC supply to the stator winding create rotating magnetic field. This field is cut by rotor conductor. In rotor conductor there is generation of EMF, and direction of EMF is such that it always tries to oppose the relative speed, and to reduce the relative speed your rotor start rotating in same speed to the stator. So that is a working principle of three-phase induction motor. And the last point, as per Mumbai University syllabus, what are the advantage of three-phase induction motor? So three-phase induction motor का सबसे पहला advantage है, that is motor is very simple in construction. So basic advantage of three-phase induction motor, that construction is very simple. Second one, they are self-started. Like a single-phase induction motor, there is a no problem of self-starting. Then maintenance is very less. Then simple speed control. Then efficiency is very high as compared to single phase. Efficiency is very high. So these are the some advantages. That's why three-phase induction motors are always preferred over single-phase induction motor. They are simple in construction. We already observed there is a no problem of starting. That's why they are self-started. Maintenance is very low. We can do the simple speed control mechanism, and last one, that is efficiency is very high. So as for Mumbai University, only two questions you can expect from the three-phase induction motor. What is the construction of three-phase induction motor, or what is the working principle, or in short, what are the advantages of three-phase induction motor? So this is about, because three-phase induction motor is a very big part. If I got the time in future, I'll make the detailed notes on three-phase induction motor, their types, speed control. But as per Mumbai University syllabus, this is only expected in three-phase induction motor. Thank you.